points of AXI that is removed for AXI4 and some new things were added. Okay.
Yeah.
So before that, okay, let me start with AXI protocol and its features. Okay. So first, what is the full form for AXI? It is Advanced Extensible Bus. Okay. So it is a AMBA family. Okay, so interconnect. So in AMBA, there are other interconnector also like APB, AHB, ASB, AXI, other things, ACE, those things are also there. Okay, so so we are mostly not will be using ASB. Why? Because ASB works on negage of clock.
Okay.
ASB, HB same functionality, but as it is working negage of clock and mostly will be working passage of clock, so we don't tend to use it. Okay, so next APB, where it is used where there is low power, low area, low bandwidth, low frequency, this kind of requirement, then I can go for APB. Now where to use HB? HB I can use for high power, high bandwidth. Bandwidth means high frequency. Okay, AXI also same. This is also a high power, high bandwidth. So next, if it is high power, high bandwidth, then when to go for AXI and when to go for AHB. Normally AXI, it has more area, and it is more like advantage. It is more advantage than AHB. Let you have some area constant, like I cannot use area more than, like just take an example of a mobile and your laptop. Okay, laptop don't have any area, you can use it, but in mobile we have certain area constant. If within that area XI cannot be used, then we can go for AHB. If it is possible, we can go for AXI, but if it is not possible, area is less, but I want high power, high bandwidth, then I can go for AHB. Okay, next in APB.
But AXI is more powerful than AHB.
Yes, it has like, you know, more efficient, more area, it is more efficient also.
Yeah.
But if you have certain area constraint, then you cannot use AXI, because AXI it is a 5 channel. Okay. I will tell, okay, what is all this 5 channel, all those things. Okay.
Yes. Yes.
So now, more efficient. Okay. So now some properties on AXI, like what are the advantages of AXI protocol? Okay, so it is like address, burst size address. Burst size address means you just have to give the start address and required control signal. It's up to slave interconnect or slave interface calculate the next addresses. Let you want to do some 10 transactions. So you have to just like inform the slave that this is my start address. I want to do 10 transactions. Next 9 addresses will be calculated by slave interface. Master don't have to provide all the addresses, but in APB we have to provide address plus we have to provide data. In AHB and AXI, okay, just don't think about AHB, I will tell that later. In AXI, we have to just give the start address, slave interface will calculate the next address. Okay, then it is a 5 channel. 5 channel means in other things, like just take an example of APB. It is 1 channel. 1 channel means within that channel, I will be giving read data, I will be giving write data. At a time, I cannot do read and write operation.
Yes.
That this is my master and this is my slave. So I have certain values, like certain address channel, address line, data line. Now I want to perform the write operation. So write address, write data, write control signal. Next, I want to provide read operation, read address, then read control signal, and here it will provide read data. Within the same thing I am doing. So at a time, if I want to do read and write operation, I can do here, right?
Yes. Yes.
But in AXI, I have 5 channels. 3 channels dedicated to write, 2 channels dedicated to read. So at a time,
Oh,
master can do read and write operation.
yes.
So
Like dual port memory.
no. Dual port memory, what happens? Okay, in dual port memory, what happens? Can you explain me? It is,
I
I
mean,
guess,
we can
2
do,
clocks are there.
yes.
Dual port memory.
No, ma'am. We can write and read as we have dual ports. Write and read the ports are, I mean, individually will be there in dual port. So in single port, we have only, I mean, single port, so that through that port we can only either do one rewrite or read.
No, dual port memory at a time you can do write or read. Dual.
Not at a time, ma'am. We have separate ports, no. So no port
Separate
will
ports
depend.
means, like, okay. Okay, I got your point. Okay. But here what happens? Okay, but here in dual port, like here, you can implement this like a dual port. You can implement it. Why? Because, okay, if I'm writing another, okay, but what I want to say in this part, can you do write and read operation at a time in dual port memory also? Because there will be only one clock, right?
Yes.
Okay, so at a time, if I want to perform read and write operation, can I do it?
Mm, write and read operation on a different, I mean, separate ports we can do it, no, ma'am. Like a write one, read. If you put write read control signal as one and the read signal as one, we can
Okay.
write and read.
Okay,
No?
I have to go the dual port memory part again. Okay, because I don't think at a time multiple read and multiple writes we can do, but at a time
Okay.
reading and writing we can do.
Yeah,
I'm
multiple reads, multiple writes. Yeah, we will do in dual port.
okay, but I have to just check that one. Okay, because in
Yeah,
single
yeah.
port na, at a time only one thing can happen. Okay,
Yes.
or like a
Yeah.
one read or one write, but dual port we can
Yes,
have
yes.
multiple read and multiple write. But I have to check whether at a time read and write we can do it or not. Okay.
Okay. So there would be like 4 possibilities in dual port. Either
Okay.
when we are writing, it cannot read. When we are reading, I mean, when we are reading,
Yes,
when we are
that.
writing, it cannot read. Yes.
uh,
But both can be happen. Write, read. When write is off, read can be happen like this. And zero
okay.
zero possibility, no, nothing will be happen. No read, no
Like,
write.
okay. So like one thing, like 0 1, read or write
Yeah.
1 0. So 1 1 0 0 is possible.
Yes.
Okay.
Zero
Then
zero zero one 1 1. 0 1. Sorry, ma'am. 0 1 1 0 1 1 are possible. 0 0 is not possible.
0 0 means no read, no write.
No read, no write. Yes.
Okay, I have to check that one. Okay.
Yes.
Okay, but normally in any protocol, that kind of facility is not available. Okay, like
Oh,
at a
okay.
time, read and write operation. In HB also, at a time, you cannot do read and write operation. Okay.
No.
But in AXI, this is one channel and this is another channel. Like these 5 channels are there. Okay, these 3 channels are dedicated to write. Okay, so now at a
Yeah.
time, whatever the write signals, write addresses, write control signals, I'll be sending here. At
Yeah.
same time, there will be 2 other channels for read. Let I
Yes.
want to read some values. Okay,
Yeah.
then with these things, I have to provide the required signals. So at a time, I can perform write operation as well as read
Well
operation.
as read operation.
Okay. So this is not available in HB also. So as at a time I can do it means the AXI speed is more and it is more efficient. Again, as it has 5 channels means number of signals are also more. So it is like area wise more.
Yeah.
Okay. So now next thing. So what are like advantages of the AXI? 5 channels, 3 channels per write, 2 channels for read. So here the question is why 3 channel for write, why 2 channel for read. Okay, so here 3 channel for write. Okay, 1 is for address, 1 is for data, and 3 is for response. These three things are required. Okay, so address,
Yes.
master will send the address, next master will send the data, next slave will send the response, right? So this address, it is from master to slave. This data, it is from master to slave. Response will be slave to master, right?
Yeah.
So three different channel. Okay, so now for two channels for read. So why two channels for read? So read
Yes,
operation
ma'am.
also requires same thing, address,
Yeah.
data plus response. So address
Yes.
signal, its direction will be what? Master to slave. Master will be always sending the address, but
Yes. Yes.
data will be slave to master,
Yeah.
right? And response, like whether slave has read the response, like checked the whether read operation is performed or not. That response will be also from slave to master. Okay, so now
Yeah.
here, as at the end your response is from slave to master, data is
Yeah.
also from slave to master, so they have mixed these two things.
What, ma'am?
Now actually here what happens, data is from slave to master, response is also from slave to master. So while
Yes.
sending the last data, slave will
Yeah.
send the response.
Okay.
So they mixed it up and they have done two channels for data as well as response, as they have the same direction. So here what happens in the last transaction,
Hmm.
slave sends the response. But here for each transaction, slave sends the response. So now here you can tell, okay, whether each write operation happening properly or not. But here you cannot say, because at the end response will come. So at the end you will get to know that whether read operation has happened properly or not. Understood?
Yes, ma'am.
Now just look at this diagram, you will understand. Here. Okay, so this is for read. Okay, let's go to write first. Okay, so master sent address control. In address control means there will be 10 to 12 signals for only related to address. 10 to 12 signals related to write data. 10 to 12 signals related to write response. Okay, so now here address master to slave, data master to slave, but write response is from slave to master. Response will be given by slave. Okay, whether
Yes, ma'am.
operation happened properly or not. So now these two directions are different. So we have to take different channel. Now coming to
Yeah.
read operation, address same. Okay, read from slave to master, read response will also be from slave to master. So as read response is from slave to master, so at the end they will send response. Same channel. So here we don't need a extra read response channel. This can be
Yeah.
a question, why only 5 channels, why not 6 channels? Because read addresses can be, read response can be sent in the read data channel as they have the same direction.
Okay.
Okay. So now, okay. So next, okay, these are the channels. It's just 1 minute. I just forgot to show you. Yes, I did. Okay. So now here, next advantage is that, so here what the advantage we get, 5 channels means at a time, read and write operation can be done. Okay. So next is each transaction is associated with one ID. With one ID, one unique ID. So that means, okay, let here I am doing write.
Yeah.
Let write ID equal to A. Okay, so here what will happen with respect to address, I will give one ID A. There is certain like channel for not channel, certain path like signal, ID signal. Okay, so I will give A ID for address. I will give A ID for write. I will give write A ID for write response. So here
Okay.
what will happen? Okay, multiple transactions out of order can possible. So what does this mean? Let master is communicating with 3 slaves. Let 2 slaves. Okay. This is one master and master. Okay. Another slave. Communicating here, communicating here. At a time, it can do this, right? Right. Now, why it is possible? Through the ID part. Okay. So master will know that, okay, which like slave I want to connect. Okay. So now here what happens? Let this slave is working with his speed and this slave is working slowly.
Okay.
One possible is that master will normally, I'm saying, okay, master will first do the transaction with this slave. Then after completing it, master will come to this slave. Okay, but here what will happen? Unnecessary time, because slave will also take some time to do the operation. At that time, master is idle. Master is not doing anything, right? So it is like unnecessary time waste. Okay, now
Yes,
let
yes.
master is doing the same, like here right, here right. Okay, so now how slave is going to know that, okay, this one is for me, address will be sent separately, data will be sent separately. So how slave is going to know that which address for which data? So all these things can be solved with the ID. Let master send one IDA.
IDA.
IDA. So now here what will slave do? With respect to IDA, whatever the data signal comes, slave will receive those data signals only. Because master has sent IDA address to this slave. Now to this slave, let master has sent IDB. Now this slave will not receive the IDA data. It will receive the data which have IDB. Okay, now here look into the signals first. AWID. This is for address, right address. Okay.
Yeah.
Next, write data WID. Next, write response BID. So these 3 IDs must be same. Now, if I'm doing one transaction, let 3 ID I have sent AAA. Okay. So now I may send this address ID A now. After 10 minutes, I am sending data. But slave with respect to address A, slave will receive the data A. Are you getting my point? Actually, what is this? Okay, this is like multiple or out of order transactions. Out of order transaction. So first, in order transaction means what? In order transaction means I am sending address A. After that, I should send, with respect to that address, I should send the right data. Understood?
Okay.
Okay. So now let one slave is receiving faster and one slave is receiving slower.
Slowly. Yeah.
So master what will do? It will send whatever slave is receiving faster, master will be continuing with that. Whenever that slower slave is free, is idle, at that time master will send some values to that slave. Okay, so now
Yes.
it is not in order. Okay, master can slave data's addresses in any order. Any order means it is out of order. Now, how
Okay.
slave is going know that, okay, what address, what data, that is with respect to ID. With respect to ID signal, slave will decide whether it is AID means na A data. So which data has ID A, master slave will think, okay, this data belongs to this address.
Okay.
With respect to that, again, a slave will send the response having ID A. Now master will know that, okay, with respect to address A, I got the response A, so this response belongs to this address or this transaction. Understood?
Yeah.
So this is out of order transaction. It is not in the AHP.
So this ID is like in what is this ID, ma'am?
ID, you have to give a ID. Like see,
Okay.
in the college also you have some certain name. When
Yeah,
you
identity
go
card.
to but that is only ID. You can give any ID. It's up to you. There is not fixed ID. Okay, and these things we can do with the help of associative array. In associative array, if you like, they may ask you like in AXI verification what kind of array you have used. You can tell associative array. Why? Because in associative array in the index we can take any data type.
Yeah, yes,
So,
ma'am.
and we can
So
store the
randomly can
values.
pick up.
And we can store the values with respect to the index. In dynamic array,
Yeah.
we store the values sequentially. But in
Sequence
SSA,
manner.
okay, we can store it. So, with respect to ID, we have to store the address, we have to store the right data, we have to store the response, then we have to compare it.
Okay.
Okay.
Yes, ma'am. Ma'am, in starting you said that we use dynamic array for what, ma'am? Which project?
Then actually dynamic array and constraint, this will be in the Ethernet project. Dynamic array will be used in any project, like almost all project, whether it's dynamic array, queue, those things. But constraint kind of things, it comes in Ethernet. Okay, because there are certain field. With respect to that field, you have to like, there will be one field like length. One field, whatever the values, like I have to generate some values less than 500, length should be 20, like this you have to generate. So you have to work on dynamic array plus constant.
Okay.
Okay.
Yes, ma'am.
Okay. So now next, let's go and check all the signals. Next here, all the advantage also there, burst based transaction, wrap, increment, all those things. But all those things you will understand while explaining the channels. Okay. So now first we'll go to address channel, right? See, you just don't think that there are so many channels, I have to remember it. Okay. Whatever the channels we have in address, almost same channels we have in write data also. Just names are different. Okay, we will see it one by one. Okay. So first is AW. A stands for AXI, W stands for write. So AWID, T down to 0, it is just like unique write addresses. Okay.
Yeah.
Now AW for address write, then sorry, AXI write address. So address signal can be 31 down to 0. This is address. Now next is AW length. AW length means this is 3 down to 0. So this indicates the burst length. Okay. So what is this burst? Okay, now here, if you look into this diagram,
The data's length burst.
Number of transactions. Okay, just one minute. That diagram. Why it is gone.
Yeah, number of packets to be sent. Packets of data.
A number of transactions also you can see. Like here, you will be remembered easily. Now, here, if I'm talking about these things, okay, how many writer time sending? 1, 2, 3, 4. So here I can say length of transaction is 4.
Yeah.
Okay, so this is my burst. Burst size is equal to 4.
Okay.
Okay.
Yeah.
So burst length. Okay. So it is number of transfers. Number of transfers associated with the ID. Let here I'm giving AWID equal to A and length I'm giving 7. That means
Yeah.
with that AID, those 7 transactions are associated. Multiple transactions, same ID. Okay.
Okay.
Why same ID? Because if you have remembered, I have already said, like in AXI, only the start address we have to give. Next addresses will be calculated by the slave.
By the
Now,
slave itself.
I have given slave address, sorry, starting address. Then to slave, I given AW length equal to 7. Now slave will know that, okay, 7 transactions, for 7 transactions, I need to calculate the address. And for each transaction, that ID will be same.
Okay.
Okay. So associated with the ID. So now this length, okay, so length equal to, length is equal to AW length plus 1. Why plus 1? Because when it is 0, we don't have any 0 transaction. Okay, so transaction will start from 1 only, 1 to 8. Okay, so it is whatever the AW length you are giving, let here you have given 6, then your burst length, slave will understand that it is 7.
Yeah.
Understood?
Okay.
Okay, so next will be AW size. AW size, it is 2 down to 0. So it indicates the burst size. Burst size for each transfer. Okay. So now what is this burst size? Now here you are sending a data. Now what is that data size? Okay, let's not talk about the data. Okay, here address. Okay, because we are dealing with address part first. Okay, so now you are giving a address. Now what is that size of the address?
Okay.
Okay. Now here I guess 1 minute. Yes. Okay. So this size, okay, what it will be? Okay, here there are no this gap, so you may get confused. Just I'm explaining with respect to this. Whatever the concept we have addressed, same concept we have for right channel also. Address channel, right, data channel, approximately same. Okay. Now here, okay, I understood that, okay, I have to send 4 transfer or 4 transactions. Now in each transfer, here what is my size? Whatever the data I'm sending, address I'll be sending like 10000101 like this. So what is the size? 2 byte, 3 byte, 4 byte, 6 byte, 7 byte. So that information will be given by here. So this signals AW size. Okay, so
for each write data.
See, address you will be sending some address, right?
Yes.
So what is the size of the address? 4 byte, 5 byte, 6 byte.
Yeah.
Okay, now you just think, okay, slave need to calculate the address. Okay.
Yes.
Now let starting address I have given 00. Okay, now you come to here. After that, next address is 8, right?
Yeah.
But how slave will know that, next address will be 8 or next address will be 0? If it is a 4-bit transactions, then slave will calculate, okay, it will be 8. If my address size is equal to 3, then slave will again go to 0. So slaves will know that whatever the address you are sending, what is the size? How I should calculate it. Okay. So now that size in,
it should calculate so that it should be the bus size.
Yes, so bus size is equal to.
So it means the bus size is nothing but address size, no?
It is for address, na? For address, I am doing all these things.
Yeah, okay. Yes.
Okay. So this is for address, and same signal we have for write data also. This is for address only. Okay. So because the address will be sending, data also will be sending all the information I need for address as well as for data. So 2 to differ AW size byte. So now you can remember this slide. Okay, just take an example of a train. Okay, so now in the train, whatever is the engine, that you can think like a start address.
Okay.
Now whatever the dabba, big dabbas are there. Okay.
Bogies.
Now,
Yeah.
so number of dabba you can think as a length, AW length.
Okay.
Okay. So now in each dabba we have some seats.
Yes.
So
Yes.
which persons are like some data you can think I need to transfer. Now how many
Yes.
number of seats, that number of things I can transfer. So that in each
Yes.
dabba, whatever the number of seats, that number of seats
Yeah.
is provided by AW size.
Okay.
So now if someone is asking you what is the number of transactions, so from the train, if someone is asking you how many people got transferred, so you have to check
Yeah.
in each dabba how many
Yeah.
people are there into number of.
And into number of bogies. Yeah.
Yes.
Those
So
dabbas.
here it will be AW length into your AW size.
Yeah.
Number of
Okay.
data. Okay. So like this you can remember it. Okay.
Yes. Yes.
So okay. So AW burst completed. Okay. So now there is AW log. So it is some logged transaction. Okay. I will explain these things later. Okay. This log type. Log type means, okay, I have to explain it more because log type in short, okay. Let master wants to do transaction with slave A,
Yeah.
read, then write. What is
Yeah.
the chance that let master is doing transaction with slave A, in that time another master came, he started transaction with the slave A. Then whatever
Yeah.
the transaction first master was doing, that transaction may get corrupted due to the second master. Now just think here. This is one slave. This is master one, master two. So master one was reading something from here. Then let writing something from here, writing something into it within this to this address. In between this, something happened so that master two started writing here. After some time, master two disconnected, again master one started. So whatever the things master one supposed to write from here to here, now that data get corrupted. Master one wanted to write something, but already master two has written something. Now let master one want to read. Then whatever the data master two has written, master one will read that data. That means this place get corrupted. I don't want this kind of transaction, so I will perform logged access. It is some semaphore kind of thing. So master one will log the address, log the slave one. So as long as master one is not completing the transaction with slave, no other master is allowed to do transaction to that slave. It is like master one is locking the slave one. Understood?
Ma'am, will you repeat once?
Let master one is doing some transaction with slave one.
Yeah.
It is writing something. Then it need to read something. In between that, master two came and it written something into the slave. Now, when master one will read something from the slave, it will read the data come from master two. This data also it can read. You can see, okay, now let master one is writing in red. Written red, red. Now, between something happened, master two came, it has written in green. Now, when master one will read, it is supposed to read only red values, but it will read also the green values. So I don't want that kind of transaction. So what will do? Master one will log the transaction with slave one. It will send that logged signal. So logged signal it is sending means no other master is allowed to do transaction with the slave.
Okay, so that is called log.
Logged.
So
it is some semaphore kind of things.
Okay. Yes,
log type transaction, it is some semaphore. In system look, we have a semaphore. Okay. Then AW get 3 down to 0. Then AW protection. There are certain things you have to remember, but here what happens? Okay. When we are testing, we'll be testing all possible combinations for length, all possible combinations for size, all possible combinations for log. But here, according to specification, this is fixed. Like these two things, whether your memory is catchable or not. Protection means whether it is read only, write only, both read, write, bufferable. All these informations are there. So for like project, these things will be fixed. Okay, like it is not going to affect your write, read operations. Okay, it is
Yeah.
just whether whatever the AXI you are working with, that address is only for read, only for write, whether it is catchable or not, those information will be provided by these two signals. We will see it later. Okay. And next
Yeah.
one is AW valid, AW ready. AW valid, AW ready, it is for handshaking purpose. That means master is sending some address. Whether
Yeah.
that address is valid or not, this
Yeah.
valid signal will give. Now coming to AW ready. Now
Yeah.
slave want to do like send some data to master. Master should send a ready signal.
Yeah.
Now let master want to write into the slave. Slave should
Yeah.
send a
It's
ready
ABC.
signal. Okay, that
Okay.
yes, I am
Fine.
ready to. Okay, so this valid and ready, it is for handshaking purpose. Handshaking means, if you remember in UVM, we have
Yes.
handshaking between sequence and our driver, like through the sequencer. That means one is sending the signal, another should give a response whether I am ready or not. Whether
Yes. Yes.
and first signal also send, okay, this signal I am sending, whether it is a valid signal or not. If it is not a valid signal, then slave don't have to receive it. So it is like some
Yes.
handshaking mechanism. Every channel will have this valid and ready. Now, how will
Yeah.
you remember? Okay, just think, okay, for address ID, AXI means I need a ID. Okay, next I
Yeah.
need to send address. So next will be
Yes.
address. Then
Yeah.
two things required. One, just think of a train. Okay, two things required: number of doubles plus each
Yes.
people in the double. So number of doubles means AW length. Each people
Yeah.
in the doubles means AW size. Completed.
Yeah.
Next,
Yes, ma'am.
valid and ready. Valid and ready signals should be for all channels. So these things you
Yeah.
remembered. Next three signals are your lock, catch, protect. Okay.
Yeah.
So same thing I will have for the write data. This is write address completed.
Yeah.
Now write data. Send the write data channel WID. Okay, so here A was for address, not for AXI, it was for address. Address write. Okay, now here W
Okay.
stands for only write. So WID will be there. W
Okay.
address
No.
will be there.
Hmm.
So unique ID for AXI write.
The above one is address right ready, ma'am. What is this AW? AW.
Again, tell me.
The above one. I mean, previously we written no, for address A.
Hmm.
A after we written W. No. So what that
So
right
address
address?
can be for read, address can be for write. So AW means address for write.
Oh, okay. So okay, ma'am. Understood.
Okay. So write ID, write address. So address signal. This is not address. This is data. Okay. So now W length means burst length, number of transfers associated with that, and it is with respect to your write. Okay.
Yeah.
So now I just have to remove this W.
A.
Sorry, A. I have to remove this A. Okay.
Yeah.
See, if master is sending address, let ID equal to A.
Yeah.
Master send ID A. Okay.
Yes. Yes.
With that ID A, it logged the transaction. So here also, you have to make sure that this ID equal to A. If this ID equal to A, then here logged access. It is not like that address will be sent logged and data will be sent without log. No. Okay.
Okay.
See, then you can easily remember these things, right? There are so many
Yes.
signals, but in this way you can remember. Okay.
Yeah.
Okay, sorry. I just 1 minute. No. Actually, these things for right addresses. Just 1 minute. Right address, read address signals are same. Okay. So here data. So first there will be WID. Then there will be W address. This is W data. Okay. So here it is AXI, right ID, and here right data. Okay. Then these signals are not required because it is already given with respect to the address. Okay, as I said, okay, if with respect to IDA, I am giving in the address lock means in the right also we have to make sure it is locked type. So that's why these signals are not required here, because by default,
Okay.
whatever the value I'm giving for address, same values I will be giving for data. So I
Okay.
don't require this signal. I can take the address signals with respect to that and I can do the calculation. Okay, so these signals are not required. And
Okay.
this valid and ready, I have already told you it will be with every signals, valid and ready. Okay. So here there are two extra signals you have to remember, W last. These signals also it is not required. Why it is not required? W last means it is the last transaction or last write value. See, already with this length, na, slave will have
Yeah.
calculated how many transactions are there, which transaction is
Yes.
last. But still they
Yes.
have added this W last signal, okay, to check, okay, this is my last transaction. Okay.
Hmm.
Now another is W stroke. This is for which byte length is valid data. Actually, let W stroke size I am taking as 8-bit. You can take it according to your requirement, but maximum size can be up to 16 also. Let I'm taking 4. Okay. Now I'm sending let a 1 byte data. So here 1 byte, 1 byte. I send some 1 byte data. So here what will master check? Okay. Whether this strobe value, this is my strobe signal. Let strobe signal value I have given 1, 0, 1, 1. Then master will understand that, okay, this data I need to store, this data I need to store, but this I don't need to store because this byte line is not valid and this data I need to store. So which data is valid, which data is not valid, this thing. Sometimes what happens now, we are sending some data with respect to data, we send some coding, we do some encoding and we send it. Okay.
Yeah.
So that encoding part later we may have to discard it. Okay, don't store that encode part, just store the data values. So at that time we can use the strobe signal. For encoding part, we can make the strobe values with 0. So it is invalid. Just store the, let in the Ethernet also. Okay. First 7 byte I am sending data. Last 1 byte is my parity. So parity I need to check whether my data is correct or not. But I don't need to store that. I need to store only the information. So that parity bit I may discard it. So like master don't need to store it. So at that time I can make that strobe 0. Okay.
Yes.
So this is the right address. Okay. So next going to write response. So in the right response, first will be BIT. B stands for response. Okay. So this suffix B you have to add. Okay. BIT, it is like ID. Okay. And response comes from slave only. Okay. Then B response signal. This is the right response. Now with respect to there be one V valid and V ready. Okay, so now here this valid and ready signal, it's like direction will be from point to point. So AW ready means, sorry, AW valid means it is like master is sending the valid data. So it is like master to slave.
Yeah.
Now who will send the ready signal? Slave to master. Okay. Now here valid means master is sending the data means master to slave. Now here ready will send by slave to master. Okay. Now here valid signal is given by slave to master. So sorry, ready, valid signal is given by slave to master. Okay. So now who will give the ready signal? Master to slave.
Okay.
Because response is given by slave, na? So slave will send the signal, okay, this response is valid or not. So master will send master to slave. Okay. So this is for write. Same thing I can have for read, but read don't have the response channel. So response will come with the read data. The same thing
Yeah.
I can copy paste. So read address channel. So for the read, I can use ARID. So unique read address signal for read, same, almost same. So I just AR address, then how length, then byte size, then log transaction or not. Yeah, protection. 30. Okay. So this thing, so wherever I have written right, you can think it as a read also. Same signal, no extra signal is added here. Okay.
Okay.
So now next go to read signal. So in the read signal, I have read ID. So this read response signal is not there. Okay. So read ID. So read data. And read valid, it is from slave to master. Because slave will be sending the data, na?
Yes.
Slave to master. Master to slave. Okay. So now here, what is the extra signal I need to add? R response. In that, I was another channel for B response, but here in the read channel only, I'll be sending. Okay, R strobe is not here. Okay. This strobe is only for write, not for read.
Yeah.
Okay, so here R response. Response signal, whether transaction is successful or not. Okay. So
Yes.
see, tomorrow if possible, I will take 1 hour class. Okay. So that in this
Yes.
week we can finish this AXI. But see, just for now, remember all the signals plus its uses. Okay. Like why
Yes.
I'm taking a tomorrow I'll be explaining you a handshake between like how the transaction happens. There are so many signals, na. So there
Yes.
should be some rules between them. Okay, this signal is high, this signal is low. I need to take the data like this. So you just
Okay.
have to remember all the signal names. Okay.
Yeah. Okay.
So this is for today. Okay. So if you have any doubt, we can discuss this tomorrow and try to just modify your resume. Okay.
Yeah. Okay.
Okay. Okay. Bye.
Okay, ma'am. Bye.
You
Have a
have
nice
any
day.
other doubt?